All right, we're going to go ahead and get started. For what we're doing today, we're going to determine whether it's linear or exponential. So we're going to decide, given some kind of information, whether it's an equation or a chart or something like that, what we have, linear versus exponential. So remember, this is a linear function. It's a single x. And then on this one, x is the exponent, so it is exponential. On the linear one, what is your y-intercept? Where do we start? Guys, you're going to have to answer because there's like 3 people on Zoom. So there's a whole like 6 of you in class today. What's your y-intercept? 3. Remember, it's where we start. For your exponential, don't forget your y-intercept is the one that's in front. So it's your y-intercept and then your multiplier. So what is your y-intercept on your exponential? 3, also 3. Your rate of change for your linear is going to be the number with x, but we call it the slope. You are correct, 2. And then for exponential, it is also the 2, but we call this the multiplier. Okay. If I write linear as a next noun, this one is going to be next equals now. We're always adding, and our rate of change is 2. We're adding 2. We started at 3. For exponential, it looks almost exactly the same, except for it's called a multiplier because we multiply 2. And we started at 3. And like I've already told you, the function type, this one, the first one is linear. The second is exponential. All right. Line of best fit. After researching the effects of a new insulin on several patients, a biologist created this table of the data. It says, describe how the amount of drug in milligrams changes over time. So what's happening?
Going down.
Okay. By how much? How would you figure that out? How would you figure out how much it was going down? Subtract it, thank you. You can do the first one's 42.5 minus 36. Or you could do 36 minus 30.7. You guys see how it's a little bit different each time? So, is this one linear? What do you think it is? Exponential. How do we tell if it's exponential? You do the opposite. You reverse divide. So 36 divided by 42.5. And then you would do 30.7 divided by 36. And if you look, it's about the same each time. This one's a really crappy example. I don't even like it. So what are we going down by each time?
0.85.
Yeah, approximately 0.85. So it decreases each hour by 0.85. It says, what is the initial value? I'm going to just go ahead and tell you this one. And when we get to another example that's a little bit better, I'm going to give that one to you, okay? So remember, to find where we start, we go backwards. So we were going up by 1 hour, so we're going to go backwards 1 hour. and the 0 is always where you start. And if we do our divide, it's going to be at 50. So how did I find that? I went backwards, 42.5 divided by 0.85 gave me 50. So then remember, this is exponential because we're multiplying. So I'm going to skip the equation for a minute and I'm going to write the next now. Next equals now. What's our multiplier? How much do we change each time?
5.85.
And where did we start at?
50.
Perfect. So then when I write my equation, it's y equals, where did we start at?
5.85.
Where did we start at? 50. Our multiplier goes in the parentheses, so 0.85. And then it's exponential because x is the exponent. I'm going to show you a better way to find this than having to look at the chart. You can use your calculator the whole time. Okay, you can use your calculator. So practical domain and range, I'm going to get outside of that and we're going to move on. Okay, so don't worry about practical domain and range right now. All right, so this is a much better example, much easier to look at. It already has your starting point. What's happening each time?
Going up by, it's doubling every time you go.
So doubling each time. Remember, doubling is times 2. What's your initial value? What did we start with?
Yeah.
1. We started with 1. 0 is where we find where we start. So this number is our start, whatever is with that 0. So we started at 1-fold. So what's our equation? Y equals, we know it's exponential because we're multiplying. So where did we start?
1.
What's our multiplier? What are we multiplying by?
2.
And then it's to the x. Again, if you're not getting it from the chart, I'm going to show you how to do it on your calculator, so don't freak out too much. Next equals now. What's our multiplier?
2.
Times 2. Where did we start?
1.
Don't worry about practical domain and practical range. All right, so now this is where it gets a little more complicated. I'm going to show you 2 ways. I'm going to show you on your calculator, which most of you have on your phone, or I'm going to show you on Desmos. So if you don't have your phone, you have it there. Desmos is a lot harder to do than your calculator, okay? Desmos is a lot harder. So what you're going to do, if we're looking in our calculator, and you guys can do this either way, I don't care, Desmos or calculator. You can always go back and look at these notes too. So if you get home or whatever and you're not sure how to do it. So we're going to go to stat. That's the button right here. So alpha X stat. And we're going to hit enter on edit. It'll bring up a list. If there's stuff in there, just type over it. It's fine. Put all of your X's in L1, 2, 3, 4, 8. You guys done this before? Should have. Okay. You should have already done this before. All right, in L2, you're going to put your Y's, 10, 13, 16, and 28. Do very good. All right. So then you're going to go to stat. Let's hold on just a second. I'm going to go to mode and make sure my stat diagnostics are on. If you don't have that on your calculator, it's going to screw you up. Okay, so make sure those are on and you just highlight it and hit enter. It turns on. Stat, calc, 4 is linear regression. We've already done this before, linear regression. So I'm going to hit enter. And then you guys see this little R right here?
Yeah.
It's 1. 1 means it's perfect. Okay, 1 means it's perfect. All right, let's look again. I'm going to go to stat, calc, and I'm going to try exponential, which is the 0. Okay, 0. Look at your R on this one. What's it say?
0.99.
So 0.99, which one's better, 1 or 0.99?
1.
1. So which function is this, linear or exponential?
Linear.
All right, so this one is linear. We're going to write all our equations out. So describe the change in y. What's happening each time?
It's going up by 3.
Yeah, see how we went 2, 3, 4, but then we did like 8, 28. So that one's way out of the range. Okay, so I'm going to just mark that one out. We went up by 3. That'll also tell you that it's linear. That's what we did on the first page. So y equals, how did it increase? Mm-hmm. And then to get my y-intercept, I got to get to 0. So if I added 3, how do I get backwards?
-2.
So what's 10 minus 3?
7.
And then 7 minus 3 is
4.
4. Okay, let me show you this one more time. Stat, calc, linear regression. What two numbers does it give us?
3 and 4.
3 and 4. So there's your equation. You don't even have to do it by hand. You can, but you don't have to. Okay. Then it says do the exponential equation. So we go to stat, calc, exponential. It's going to give us some crappy numbers because it's not perfect. And our equation would be y equals 7.7 times 1.2 to the x. We said our r for linear was 1. For exponential was 0.99. So linear is the better choice. All right, so let's do it again. Look at the next one. We can do it by hand. What's happening? See how this goes 1, 2, 3, and then it says 6? Don't worry about 6. Okay. Just look at 1, 2, and 3. What's happening each time?
It's going down by negative 2.
Not -2. What are you doing? What?
Dividing by
Dividing 2. Absolutely. We're dividing 2 each time, right? Is everybody good? So is that going to be linear or exponential? It's going to be exponential. Okay. It's going to be exponential. I just circled exponential. So then we're going to put it in our calculator. Like I said, you don't have to put all of them in there. You can just put the first ones. 1, 2, 3. We can delete that one out. 20, 10, 5. Delete that one out. I'm going to show you the linear one first. The equation is y equals negative 7.5x plus 26.7. What's our r though? What's our r? Negative 0.98. Negative 0.98. Negative means it's decreasing. Then I'm going to do stat, calc, exponential. And we're going to calculate. And it says our equation is y equals, we start at 40. Our multiplier is 0.5. That's 1/2 dividing by 2. To the x, and what's our r?
1,
Negative 1. So which one is better?
1.
Exponential, just like you said. So there's a couple different ways you can do it. So now what I'm going to do is actually show you this one on Desmos. So I got to stop my share for a minute. And show you how to do this. So what you're going to do to, y'all, this is complicated, okay? This is why I said it's a little bit complicated. Go back and look at it if you need to, especially when you're taking your test. If you need to and you're using Desmos, go back and look at the video. It's okay. All right, so you do parentheses. My first coordinate was 120, okay? I don't think everybody's seeing this. Let me get back to it. Hold on. Share screen. My Desmos is here. Okay, sorry guys. So 120 is your first coordinate. 210 is your second coordinate. And 3, 5 is your third coordinate. You can go up to that little gear, and when I click it, it'll show me a table. But I have to change this to X1, Y1. All right, so one more time. Put in your points, change it to a table by clicking the gear, and then make sure it's X1, Y1. All right. In Y2, you're going to type in your equation. Y1 is similar to mx plus 1, mx1 plus b. That, you may need to write that down. That is going to be your linear, okay? Look at your R value. I don't know if you guys can see it. I can't make it do anything, but your R value is that negative 0.98 right there underneath your variables. Everybody see that? Yes? You guys see that? Okay, good. The next time you're going to put in Y1 and that little squiggly line, that's shift in the very top key before escape. We're going to put in A, B to the X1. But you have to click log mode on that one. So then you can see your R is a perfect -1. Once you have this in, all you need to change is that first thing, the table. So these can stay and you can just change the table. Does that make sense? All right, so let me look at the one before that. I'm going to move it up and I'm going to change my table. We had 210. We had 313. And notice how it's changing my values down there. And we had 416. So if you guys look, it's going crazy. I don't know why it's got a third column here, but let's do it one more time. See if we can get it. Let's do it a different way. Parentheses, 210, 313. I can't type today, so y'all are gonna have to bear with me. 416. Make sure you put the commas in because they get mad at you if you don't. Put your table in. There we go. Remember, change this to X1, Y1. And then Y and a little squiggly, sorry, Y1 and a little squiggly. MX1 plus B. There's your R value. Then Y1, A, B to the X1. And again, we got to put it in log mode to be able to see R. And you guys can see that linear was the better choice for that one. Desmosis, yucky on this. It's not the easiest thing to use, but you can do it. You just got to remember what to put in. Okay. I'm going to keep going with this. Let me figure out where I got to go. Stop share, share back to my screen, and check out the next one. Okay, check out the next one. Sarah was sitting on her porch and she counted the number of gnats each hour. The first hour there were 20 gnats, the second hour there were 35, the third hour there were 60, and the fourth hour she counted 80. So describe the change in Y. What's happening? What's it doing?
Going up every hour.
Yeah, you can just say increasing. All right. So we're going to go into stat and we're going to edit our chart. It said the first hour there were how many?
First time?
Yeah,
20.
20. So our coordinate is 120. So that one stayed in there. The second hour there were how many gnats?
35.
35. So 235. The third hour there were
60.
60. And then in the fourth hour, there was 80. We're going to go to stat, calc, and we're going to start with linear regression. And it said y equals 20.5x minus 2.5, and our r is 0.99. That's pretty close, right? 0.99 is pretty close to 1. Do it again, stat, calc, but do exponential this time. It says y equals 13.23 times 1.6 to the x. What's our hour value?
199.
Oh, so, but this one was 199 or 0.990, and this one was 0.995. So what do you think we should do from now on?
Round up.
3 decimal places. Don't round up, just go 3 decimal places and see which one's better, okay? So which one's better, 0.995 or 0.990?
195.
Perfect. So we're going to go with the linear one. Do it again. We're going to change our stat. We're going to edit. Our coordinates are 0, 1, 2, 3, 4, and 5. Our values are 300, 164, 100, 46, 20, and 8. Once you put those in, check both equations. What's happening each time though? Like, are they increasing or decreasing? If you guys watch, when we get our R values, they'll both be negative. Okay, decreasing. Stats, calc, linear regression. We got y equals negative 55.6x plus 245.33. What's our R value?
Negative 134.
Point what?
134.
9368 or 67. Stat, calc, go to exponential. Our equation is y equals 348.23 times 0.48 to the x. What's our R value?
0.994.
Which one is better?
Exponential.
Exponential. That's all you do. That's all you do. All right. Contextual, linear, or exponential, you have to know if it's adding each time, it's linear. If it's multiplying each time, it's going to be exponential. So a savings account, which earns no interest, receives a deposit of $723 each month. So add 723, add 723, add 720. What is that, linear or exponential? Linear. The value of a machine depreciates by 17% per year. Good. Every week, 9/10 of a radioactive substance remains from the beginning of the week. Good. A liter of water evaporates from a swimming pool every day. Why is it linear? It's taking away the same amount each time. A percentage is not, okay? It will not be the same amount each time. Every 124 minutes, half of a drug dosage remains in the body. Exponential. You'll have to do that on your test, so be ready for that. All right, last page. Oh, maybe not the last page. I lied to you. All right, comparing functions. These are really, really simple. Jack and Sally play a game. Jack starts at 0 points. Each turn he increases by 100 points. Sally starts at 25 points. Each turn she doubles her points. After how many turns will we have the same amount? So we have Jack and Sally. Before they even begin, how much does Jack have? 0. How much does Sally have? All right, each turn she doubles. Each turn he increases by 100 points. So here's Jack. On turn 1, how much is he going to have? Turn 2. Somebody else, turn 3. 4 is 400 and 5 is 500. Sally doubles hers. So after the first round, what is she going to have? Next. Keep going. And then? And then 800. It says after how many turns, be careful about this, after how many turns will they have the same amount of points? Where do they have the same amount of points?
4.
That's it. That's all you have to do. Jack's was linear, Sally's was exponential. Okay. The population of Rabbitville increased exponentially since 1980. In 1980, the population was 2 million. In 1981, the population was 2.5 million. The population of Turtletown increased at a constant rate of 150,000 people per year. The population in 1980 was 4 million. How many years does it take for Rabbitville to become more populated than Turtletown? So we have Rabbitville and Turtletown. And in 1980, which was the start, so that's a 0, how much did Rabbittown have? 2 million. Turtletown had how much?
2.5 million.
No. Mm-mm. Turtletown had how many? 4. All right. So in 1980, the population was 2 million for Rabbittown or Rabbitville. In 1981, or one more year, the population was 2.5. It increased exponentially. So how do we do that? How do we do that? How do we figure out the distance if it's exponential? What did I tell you to do? Divide. So 2.5 divided by 2. What do we get? 1.25. So 1.25 times 2.5 gives you 125. Times 1.25 gives you 3.906. Times 1.25 gives you 4.88. I'm going to stop there. It said Turtletown increased by a constant rate of 150. So the way we would write this is 4.15. So we're basically adding 0.15 each time. So what would the next one be if I added 0.15?
4.3.
If I add it again,
4.45.
and the last one,
4.50.
okay. If I go on to 5, I'm gonna go ahead and give you the numbers. We get 6.1 and 4.75. It asked, how many years does it take for Rabbitville to become more populated than Turtletown?
4.
4 years. What year would that have been?
1984. Yeah, 1984.
Good. That's all you do. Okay. The number of bacteria divides into 3 every 15 minutes. There were 3 bacteria at 1 p.m. The number of bacteria 2 divides into 7 every 4 hours. There were 3 bacteria at 1 p.m. All right, so bacteria 1 divides into 3 every 15 minutes. Start with 3. So y equals, what do we start with?
3.
If it divides into 3 every 15 minutes, what are we actually doing to the number? So 1 splits into 3. 3 splits into 9. Keep going. Yeah, multiplying. Multiplying by 3 to the x. What about bacteria? It divides into 7 every 4 hours. So how would I write this one? What do we start with?
3.
3. If we use 3 as our multiplier when it said it divides into 3 every 15 minutes, what do we use for our multiplier on this one if it says it divides into 7?
7.
Good. Now be careful because this x represents 15 minutes or the number of 15 minutes. And this one represents the number of 4 hours. So find the number of bacteria at 1 a.m. So when did we start?
At 1 p.m.
1 p.m. So how long has passed?
12 hours.
12 hours. So bacteria 1 y equals 3 times 3 to the x, but it's the number of 15. How many 15 minutes are in 12 hours? That's rough. How many 15 minutes are in 1 hour?
4,
4. So how many would be in 12 hours?
48.
Mm-hmm. And I'm going to go ahead and tell you that it's 2.39 times 10 to the 23rd. It's a huge number. So we had to write it as scientific notation. For bacteria 2, 3 times 7 to the x. Remember, the x is only for 4 hours. So how many 4 hours are there in 12 hours?
3.
So 3 times 3 to the third, which gives you 1029. Okay. Any questions on that one? Pretty simple, not too bad. All right, town A, add 10 people per year to its population, and town B grows by 10% each year. 10% each year. All right, what do we do? What do we do? How do we write town A? Add 10 people per year, but it starts at 145.
145 plus 10.
How much are we increasing by?
10.
10. So it should be a 10x. Start at 145. Okay. Town B grows by 10%. How much did town B start with? 145. You said it was exponential. Why is it 0.10? Because we had 10%. We got to change it to the x. That's all it wanted you to do. I'm not worried about how long it will take to double or anything like that. I just want to write the equations. All right. Cameron did an experiment to compare 2 methods of warming an object. The results are shown in the table below. Describe each relationship. What's it look like is happening here? Is it adding or subtracting or multiplying or dividing? It looks like adding. So this one's going to be linear. What's happening on this one? What's it doing? Thank you. Multiplying by 2, so that one is going to be exponential. You don't have to find the equations right now. I already showed you how to do that. Okay. Last one. According to Wikipedia, the International Basketball Federation requires that basketball bounce to the height of 1,300 millimeters when dropped from a height of 1,800 millimeters. So complete this chart. So after the first bounce, what does it drop to? All right. So I will tell you that it's exponential because the ball doesn't drop the same amount each time, okay? So it's like 2/3, it'll bounce 2/3 the height of whatever. So we're going to go ahead and do 1,800 divided by 1,300, other way around, sorry, 1,300 divided by 1,800 and get 0.72, so about 72%. So 1,300 times 0.72 is times 0.72 is times 0.72 is. Write an expression for h of n. H of n. So y equals, what did we start with? 1,800. What did we find out our multiplier was? What did I keep multiplying? 0.72 to the x. What would happen if the initial height were 2,000?
Get higher. Or, dude.
What would happen to the equation?
And we do your numbers in.
Where?
Uh,
Would the start be the same?
yeah. No,
Why?
I think it was start at 2.
Start at 2,000. But does the ball still bounce the same?
Yeah.
Yes, so it would still be 0.72 to the x, so nothing would happen. All right. Again, your homework is just like your notes. Guys, do your homework and then turn it in. Just make sure you don't have to do any of the, if there's any domain and range, you don't have to do that. But what you do need to do is find those equations. So do the best that you can to find those equations. All right, I'm gonna stop sharing, stop recording.